All right, my intelligent peoples, we are going on to 2.6, day 2, page 2, where we are putting it all together. We're going to find everything, the asymptotes, the holes, the intercepts. We're going to sketch the graph and give the domain. All right, so here we go. Example 2a, it's already factored for us, so that's nice. Notice the x minus 4's reduce, so that's going to give us a hole. So we look at the part that's left that didn't reduce. The x plus 1 gives us a vertical asymptote at x equals -1. If we were to multiply this out, we would get x squared over x squared, which means the horizontal asymptote is the leading coefficients. And if we were to multiply this out, it would be 2x squared and 1x squared. So y equals 2 over 1, which is just y equals 2. The slant asymptote, none. To have a slant asymptote, the degree of the numerator has to be larger than the degree of the denominator by 1. The x minus 4's canceled, so that means there's a hole when x equals 4. And if I plug the 4 in right here, I get 11 over 5. So my hole is the point 4, 11 fifths. X-intercept comes from the numerator. 2x plus 3 equals 0 when x equals -3 halves. Y-intercept, if I plug in 0 for the x's, I get 3. So my y-intercept is the point 0.03. And now I'm going to put all this onto my graph. So vertical asymptote, right there. Horizontal asymptote, straight across. No slant asymptote. Hole. So notice I put a little open circle. It's right above the horizontal asymptote, just above it. X-intercept, -1.5, 0. Y-intercept, 0, 3. And in this case, because I had points on this side and points on this side, I don't have to add any extra points. I can just use the asymptotes. The vertical asymptotes are going to split your graph into pieces. So notice with one vertical asymptote, there are two pieces, the right side and the left side. And both of these points are up here, so we're going to draw the curve approaching the vertical asymptote, approaching the horizontal asymptote. Where this point is down here, I'm going to draw the curve down approaching the vertical asymptote and approaching the horizontal asymptote. And here's a little hint. These two curves will never be side by side. If this one's on the top, this one's on the bottom. If this one over here was on the top, this one over here would be on the bottom. They're never going to be side by side. So if you end up having two curves side by side, go back and check your asymptotes or something. You might have made a mistake. And we look at the vertical asymptote and we look at the hole. So our domain is all real numbers except x cannot equal -1 or 4. Whew, long problem, lots to do, I know. All right, so B, first thing I want to do is factor. Well, 3x doesn't factor. The denominator does factor to x plus 2 times x minus 1. Nothing reduces, so there's no holes. The denominator gives us our vertical asymptotes, so we have x equals -2 and x equals 1. The degree on top is smaller than the degree on the bottom, so our horizontal asymptote is automatically y equals 0. The degree on top is not bigger than the degree on the bottom, so there is no slant asymptote. And notice I did these both in blue because if there's a horizontal asymptote, there is no slant asymptote. If there is a slant asymptote, there is no horizontal asymptote. You can never have both of them. You can only have one or none. Okay. All right, so hole. Again, we said nothing reduced, so there is no hole. X-intercept. When does the numerator equal 0? Well, when x equals 0, so the x-intercept is 0, 0. And that means the y-intercept is also 0, 0, because the y-intercept is when x equals 0. But just to remind you, if you didn't recognize that, the y-intercept, if you plug in 0 for x, this whole thing ends up equaling 0. So now I'm going to put all of this onto the graph. Vertical asymptotes, -2 and 1. Horizontal asymptote, y equals 0. There is no slant asymptote. There is no hole. The x and y intercepts are the same. It's the point 0, 0. Now, I know that might be a little confusing because it's on the horizontal asymptote, but it's okay. As long as it's kind of here in the middle of the graph, you can actually cross the horizontal asymptote. The horizontal asymptote only tells you what happens as the x goes out to infinity or out to negative infinity. Okay, so here in the middle, it's okay to have a point that crosses it. Now, that's the only point we had, so I really don't have enough information to graph. So what I decided to do is I'm going to pick -3 from the left side, -1 from the middle, and 2 from the right side, and plug these numbers in. So if I plug -3 in, I get -9/4. If I plug -1 in, I get 3/2. And if I plug 2 in, I get 3/2. So that's where I got this point right here, -3, -2 1/4, -1, 1 1/2, 2, 2 1/2. Now, anytime you have a graph like this, it's a little tricky because the middle part could look kind of like a parabola, or it could look kind of like this S-curve, which is why we had to find extra points. So this one down here is going to approach the asymptotes. We can tell this one's going to go up to the left, but here's how we know it goes down to the right, because this curve is up on the right side. And remember, we said no curves can share a vertical asymptote. So if this one's going on the upside, then this one has to go on the downside. All right, and again, we look at our vertical asymptotes and holes. Our domain is all real numbers, except x cannot equal -2 or 1. All right, hang in there, guys. I know these are tough graphs. Just hang in there. I know you can do it. All right, and last one here. First thing we want to do is factor. Well, that's not factorable, and x by itself is not factorable. So nothing reduces, which means there are going to be no holes. The denominator gives us a vertical asymptote, so x equals 0. The degree of the numerator is bigger than the degree of the denominator, so there is no horizontal asymptote. But it is bigger by exactly 1, which means there is a slant asymptote. Notice there's no x though, so I have to write 3x squared plus 0x plus 1 divided by x. So 3x squared divided by x is 3x. Multiply 3x squared, subtract, those cancel, bring down the 0x. 0x divided by x is 0, so right there is our slant asymptote, y equals 3x. And we already said nothing reduced, so there are no holes. X-intercept, when does the numerator equal 0? Well, x squared equals -1/3, that's not possible. X squared has to be a positive number. So there are no x-intercepts. Y-intercept, plug in 0 for x. Well, you can't divide by 0, so there is no y-intercept. So we have this vertical asymptote at x equals 0. We have this slant asymptote, y equals 3x. And we don't know anything else. So all I could tell you from there is that the curve would either be here and here, or it would be here and here. They'd always open the opposite direction. So it'd be right and left, or it would be up and down. So to figure out which one, I'm going to pick a number from the right side and a number from the left side. So I decided to plug in -1 and 1. When I plug in -1 for x, I get -4 for y. When I plug in +1 for x, I get +4 for y. So that gives me this point here and this point here. So now I can tell that the curve is going to open up and down. And again, we look at the vertical asymptote and the holes. Our domain, all real numbers except x cannot equal 0. I know this was kind of a long set of notes, but we wanted to make sure you had lots of examples to look at for graphing. Thank you very much, folks.